So, I talked about how I wanted to get into absolute value, okay, and I do, but I don't want to do it right away now. Just thinking about the organization of the textbook, I think it's kind of maybe backwards a little bit. Because when we start talking about absolute value equations, we start talking about set notation, basically meaning how I show my solutions, because you're going to have multiple solutions. And then we start talking about inequalities, and then when we talk about inequalities, anytime we talk about inequalities, usually we get infinite solutions. Okay, so we need to talk about the way that we describe those infinite solutions. Because if I ask you in that first question, x is greater than 5, and I ask you, what is the first number greater than 5, what is it? What's the first number greater than 5? Okay, 5 point, essentially an infinite number of zeros, slap a 1 on the end of that, right? Okay. You can't write that down, right? You couldn't even get done writing all the zeros down. Okay? So you would, just think about this. If you were writing down by hand, you would die writing that first number that is to the right of 5. Okay? So there's absolutely no way that you would be able to write all the numbers down that are to the right of 5, correct? Does that make sense? Okay? So we can't do that. We've got infinite solutions. The idea that as long as I have 2 distinct points on the number line, there's an infinite number of values, infinite number of real numbers between those two things. We have to have some other type of notation to be able to write down those values that we're implying that we want to talk about. Okay. So we have several notations to talk about. Obviously, the first one is just being able to graph it on a number line. The second notation, a lot of times they're calling it inequality notation. Eventually, we'll make it a little bit more involved and call it set builder notation. But the one that 99% of the time that we're going to be able to deal with in this class is what we call interval notation. And it's created for convenience, okay? So we can write a lot of solutions really quick. But when we do that, when we look for convenience and writing things real quick, a lot of times content and understanding, we lose a little bit of that. Does that make sense? There's kind of got to be a cost and reward type thing. The reward is that we are allowed to get a lot of answers written down real quick, but the cost of that is we might lose meaning a little bit, or it might be kind of cryptic to read, hard to read. Does that make sense? Not a lot of insight provided in the solution. So there's a lot of stuff we've got to remember here when we start doing this. It makes essentially the work that we do on computers very, very nice, okay? Because we're allowed to present these answers very quickly, okay? So it says graph on a number line. Obviously, you guys know how to do this. If we're graphing x is greater than 5 on a number line, we're going to draw our number line. All right, we're going to find 5 on it, correct? So let's just say 5 is there. All right, now, if I want to be greater than 5, what numbers are greater than 5? Which direction? To the right, correct? So I'm going to highlight all these numbers to the right of 5. Okay? But I've done one thing, or I've left out one thing that's important here. When I say x is greater than 5, we have what we call exclusion. Meaning that 5 cannot be in that solution. Alright? But this is the way I have to use this, that notation, that greater than notation. Okay, and the lack of equality with it tells me I have to be greater than 5, so that incorporates that the first number that we're writing down here, the first number we're referring to here, is the 5-point infinite zeros slap on a 1. Okay? So how do I do that notation-wise? You guys remember? Okay, you put an open dot there. Okay? Now you also have another option, and I like this other option. To represent an open dot, we use a parenthesis. Okay? And then we could draw our arrow that direction. I like the parenthesis because of how that's going to relate back to our interval notation. Okay, is that okay with everybody? You guys remember doing that? Okay. Last class told me that we've never seen interval notation. And I walked across the hallway, or across the door, and I asked the nice lady over there, and she said, absolutely, we did that interval notation last year. So this is something you guys have seen. We need to be able to use this, okay? So when I want to write this, that's a pain in the butt to write my answers as a graph, okay? Think about typing your answers out or something like that. That's not really convenient on a number line, okay? Or doing that with a number line, provided the keys that you have and all that kind of stuff. So we want to be able to write it more efficiently. So we take our number line, and we're going to rewrite it in regards to interval notation. So how you read your number line is always left to right, correct? Or if I'm dealing with a y-axis, a vertical number line, I read it from bottom up, okay? So left to right or bottom up, or in this case, left to right. What's the first number on our number line that we are dealing with? I'm not saying that it's included or excluded. It's just the first number that we highlight on that number line. It's 5, right? Okay? Whether it's included or excluded, you need that in your interval notation. So left to right, I need 5 first, okay? Now think about the last number you come across. The last number that this arrow is representing is what number? Infinity, okay? Now here's the thing. We need a notation to tell people, like our graph did, that being an open dot, that told us visually that that means that 5 is not included, but that number directly to the right, the next one over is. So we need the same type of thing to occur in our interval notation. And the way we do that is we use, in this case, because we're excluding, we use a parenthesis. Okay? So we put a parenthesis around 5, and that tells everybody that's reading that 5 is not included. 5 is not an answer. The number directly to the right of 5 is your first answer. Does that make sense? Okay? Now, infinity, can I get to infinity? Can I know what infinity is? No, because once you say you've got infinity, I always can add 1 to it, right? And I got a new infinity, and you can add 1 to that one. And we always go back and forth for a long time, and we'll never find exactly what infinity is, so we can't really get to that either, so we put a parenthesis there, okay? Something we talk about in this class is that infinity is not a number. Infinity is an idea, okay? However, the way we interpret it and we deal with it, there's a lot of nice numerical things that we can actually do with that idea, okay? But that's part of calculus. So 5 to infinity, parentheses around both of those mean we don't include 5, we don't include infinity, okay? Does that kind of make sense? Graphically speaking, and if I was standing right here on my number line, that means I can walk up to this 5, and I get my tip of my toes right in front of 5, okay? But once I stand on top of 5, I fall through the graph, right? There's a hole there. I can't incorporate that number, okay? When I get down to this one here, okay, x is greater than or equal to 5, again, I'm going to have my number line. 5's there. Greater than 5 would be to the right, correct? It's terrible. Okay, but it's all those numbers to the right of 5, right? What is the one thing that we do here differently than what we did in the last one? Okay, it's a closed dot. Okay? This equality refers to inclusion. Okay? Sometimes we say, this inequality is exclusive. Okay? So it's excluding something. It's just less than or greater than. If it's inclusive, then it's an equality. It's less than or equal to, greater than or equal to. Okay? So this one's inclusive. Okay? So again, the way I approach this, thinking about my number line, left to right, first number I come across, 5. Last number I come across, infinity. Can I incorporate or include infinity in my answers? No, infinity always gets a parenthesis. Okay? But I can include 5. We use a closed dot here. An open dot was a parenthesis, right? A closed dot, you might see written this way. That's a square bracket. Okay? The way I remember this stuff, less than or greater than provides an open dot. Okay? Or a parenthesis. Less than or equal to, greater than or equal to, that required more ink to draw than those did, right? So that should incorporate a closed dot because that incorporates more ink, right? And if I sit and think about it, is that more ink to make that bracket than it was to make the parenthesis? Okay? So when and the thing about more ink means more solutions, right? There are more solutions right here than there are here, right? Does that make sense? How many more? Just one, okay? That aspect of more in regards to inclusive might help you remember what notation to use around those values, okay? On Monday, we'll pick up and talk about the rest of these. We'll do some problems, write our answers in the interval notation, and then hopefully that should segue us into inequalities, absolute value and absolute value inequalities real nicely, okay? So that is the plan for next week. Maybe a couple quizzes too.